Welcome to this Fine Home Building webinar. This is Fine Home Building Contributing Editor Ian Schwandt. This is the important role of a WRB webinar brought to us by Henry and Fine Home Building. Today we will be discussing the many benefits of WRBs, including their installation details and other considerations, which products to choose for different applications. And then at the end of the webinar, we will discuss Randy Williams' recent Fine Home Building article on the practical perfect wall. Joining me today is the author of that article, Randy Williams, editor of Green Building Advisor, and Tom Beata, product manager for residential and light commercial wall systems for Henry. Tom manages a diverse portfolio of leading building envelope products, including WRBs, self-adhered and liquid flashing products, and integrated WRB products. I want to thank everyone for joining us today. Please feel free to put any questions that you have for Randy and Tom into the Q&A feature on the webinar. I will be working the Q&A while Tom and Randy are talking through the various WRB offerings that Henry has, focusing on the Blueskin VP100. And then again, when we are talking through Randy's Practical Perfect Wall article. Randy and Tom, I want to thank you both for joining me today. I want to thank everyone out there for joining us. And especially I want to thank Henry and Fine Home Building for giving us the opportunity to talk about the important role of a WRB.
So we'll take it away from here. Like Ian said, Tom Beata, I'm the product manager for our building envelopes products for Henry for residential exterior walls primarily. So going to begin talking about the role of WRB. So Ian, if you could go to the next slide. So today we're going to be focusing on the wall, but of course it's important to think about and manage water and moisture throughout the home, right? Starting at the roof all the way down to the foundation. So looking at products that protect the typically wood-based sheathing of the roof and the wall, and making sure that there's no intrusion at the foundation as well. So we'll focus on the wall and particularly the WRB today. So looking at water-resistive barriers, of course, there's a number of types of products out on the market today, from your traditional asphalt paper to many synthetic types of WRBs, woven products, non-woven products, and on down the line up to a self-adhered as one of the highest tier of products. So we'll talk through some of that today as we get into this. So in terms of thinking about what a WRB actually is, I thought a good place to start would be looking just at the code in the IRC. So if you look at what the 2024 IRC has in R703, essentially what it calls for is a wall envelope that's designed in a way to prevent water accumulation in the wall assemblies. And specifically, we're looking for a water-resistant barrier behind the cladding, combined with a means of draining that water, any water that gets behind the cladding, away from the wall. So that's kind of the key piece of a WRB, making sure that that wall behind the cladding is protected. A key piece of that is integrating that WRB with flashing, which Randy will talk about how he did that for his perfect wall scenario. And we'll talk through some more details there as well. Kind of taking that a step further, if you look at that previous slide there, Ian, just looking at R703.2, it gives some specifics about what's actually required and where it's required. I mentioned that it calls for the WRB to be installed behind an exterior wall veneer behind the cladding. I saw an interesting update that I wasn't previously aware of, that the 24 code actually calls for it behind deck ledgers as well, which is a great detail for continuity of the air and water barrier as a part of the wall.
Randy, could you speak to why that would be important to have that product behind a deck ledger?
Yeah, it often, well, number one, often it gets wet back there. We're starting to see deck ledgers that we're holding off from the wall just a little bit to allow some drainage. And matter of fact, some decks are actually not even attached to the house, but the ones that are attached to the house, we want that drainage space back there. And of course, we don't want the sheathing portion of the wall to become wet. And it also, like Tom mentioned, continuity of the air barrier. That's a pretty it can be a leaky area. You're usually at the rim. It might be higher in the assembly too, but at some sort of rim, you're obviously not wanting to have air move through that assembly at that point.
Yeah, like I said, I thought that was an interesting thing that I caught there, and like you said, Randy, is definitely worth noting as there's been an evolution there, many details that are out there now, especially as you start to think about continuous insulation and how that integrates at a deck as well. Of course, the code was based on asphalt felt, but has evolved over time. We'll talk a little more about that. In terms of what a good wall system and a good wall system design, we talk about the 5 Ds of wall design here for a WRB. That's deflection, drainage, drying, decay resistance, and doability. How making sure that it's actually practical to install in the field. I think Randy, you've had a lot of experience there, figuring out, especially as you look at continuous insulation, those details for doability, right?
Yeah, yeah, and they're not always simple. It's always easier not having to deal with
Sure,
with continuous insulation, but yeah, the codes are
absolutely.
changing. Yeah.
When you get into the doability piece, I would put this to both Tom and Randy. How important is it to be working with a product that is part of a larger system of products to achieve window installs and some of the other details that we'll go over later?
Think there's a big advantage to um, having one point of contact from a manufacturer or supplier that can provide all of the above. That way, you know you're getting a complete system. To answer your question, Ian, I think it's very important to have that as a full system and to be thinking about it in that way, to think about the overall performance and how things tie together, especially at the complex detail level, like you mentioned, Randy.
Yeah, there's compatibility is a big part of that. Certain products and sealants and caulks, some of that does not like is not compatible with other products. So you're sticking with one family of product, such as the Henry product line. For me, it's what I try to do. There are times when, of course, I choose another product, but for the majority of the time, yeah, I'm using one brand of product throughout the whole build.
Yeah, it's a great point about compatibility, Randy. Well, I've gotten a lot of questions over the years about is this product compatible with that one, and it's a great way to ensure using a system that you don't have to worry about compatibility. So as we look at, we've mentioned the Blueskin VP100 product. This is a self-adhered WRB, and if you're not familiar with a self-adhered, there's a lot of advantages to that type of product. I think one of the biggest advantages you get there is that it has the ability to self-seal around nails and fasteners for the cladding that's ultimately going to go over that wall. I always like the image that's there at the bottom, right? You have a jar with some water in it, put some nails through the VP100 and turn it over, and it doesn't leak. I think it's just a good demonstration to show how that actually plays out when you install it on the wall. In
How important is that, Randy, when you're putting exterior insulation over the WRB on the exterior of the wall as you did in your article?
Yeah, I mean, you're going to have to fasten that insulation on somehow, right? And then in the article, we also have spring strips that are for the cladding attachment. That's going to go all the way through the insulation, through the WRB and into some kind of wall structure. In our case, we were into the wall framing. Um, Having that, yeah, you want it to seal. You don't want to have a bunch of holes. That's the main purpose of this is to keep water out of the system.
Another advantage you get with a fully adhered product is kind of that third bullet point, right? You're blocking any air leakage. There's no opportunity for that air to flow behind the membrane and the sheathing. That goes for both air and water. Of course, detailing is probably the most important, right? In terms of water issues, it the large majority of the time comes down to the detailing, but having that barrier that's fully adhered gives you that extra insurance for a product like that.
One other thing that I like about having it fully adhered is it's much harder to blow off the building. A, a,
Definitely,
a lot of the mechanically attached products, you go by and they're flapping in the breeze, or and once they start that flapping, it's like a tarp on the back of your truck, right? You're going down the highway, and that flapping actually damages the product, and it will no longer perform the way it's supposed to. So that really needs to be taken off and replaced. It's going to take a lot to get the self-adhered to peel off just due to wind.
for sure. Right. Yeah, and
So
as the
Tom, I wanted to jump ahead to this next
yeah,
slide about perms because we are getting quite a few questions about different perm ratings and when is that permeability important or less important. And then Randy, something for you in that is coordinating the permeability of the WRB with the sheathing product that you're using.
yeah, the permeability and drying potential discussion is always a good point to consider as you're thinking about your overall wall assembly. You can see here that Henry offers a range of products down from about 8 perms up to the highest we actually have is in the residential space is the VP 100 at 33 perms, which is a high perm product. The higher the perm, that it allows for increased drying potential for that wall system, right? Any unintended air leakage or anything of the sort that can bring moisture with it, you're allowing it to escape out. One kind of I wouldn't say rule, but the way I've always thought about it is you don't want to impede the drying potential of the wood, right? From what I've seen in some of the building science, a rule of thumb is somewhere between 10 and 20 is a good balance for doing that. Of course, you can see here we offer products that are slightly below that, but they're around that 10 mark. And there are certain times where there are considerations that folks have for a lower perm product as well. So having a range of products helps to address that as you think about different climates and installation practices across the country.
Yeah, I like that little bit higher. That 33 is what I consider about perfect, at least for my climate. I'm in climate zone 7. I'm in a very cold climate. Um, a lot of times what we see in the wintertime is a condensation issue on the interior side of that sheathing where things get damp. And the drying process through wood or OSB or plywood it's slow. It's not quick. As soon as it gets out, we want it to get it out of the rest of the system as quickly as possible. We do not want it getting trapped, and that's why we have, at least I like to see that little bit higher perm. Get the stuff moving as quickly as it can. It's limited by the wood, but so once it gets past the wood, it gets to the WRB, it's able to move a little easier. We're able to get the moisture out.
For sure.
I
How does that perm rating compare to, old school methods like tar paper, Randy?
Tar paper, I think, is a little bit lower. I don't quote me, but I think it's in the 10-ish or single digits even. But then you've got on the other side, there are some mechanically attached WRBs that are in the 50s.
Right.
Some of the, um, the way that one of the things I always look at is look at your cladding, and of course your if you're putting it
Right.
on a vented rain screen or something like that, if you have a cladding that really restricts drying, you're going to want something, and if it's able to absorb, like stucco, for instance, you're probably going to want something a little bit tighter. You're not going to want to have a very open system because being open on the outside will also allow water to or moisture to move through the WRB easier. So if you have a cladding product that absorbs moisture, tighten that WRB up just a little bit. If you're in with the lap siding, the vinyl, steel, anything like that, you can open that WRB up a little bit more. Let that moisture come out. You have less of a chance of the moisture moving into the wall from the outside. So it's better to have it drying from the outside in.
Yeah, that's a great point about cladding types there, Randy, especially, there's a lot of considerations about stucco as there's been issues over the years. Codes are starting to move in the direction of requiring some of the drainage and drying potential behind stucco. I'd highlight there about in the middle of this chart, the Weather Smart rain screen is a rain screen product that provides a standoff from the actual WRB layer. So it provides that drainage and drying ventilation potential behind the stucco, serving as that second layer of WRB, where something like the VP 100 or any other one of these products could be your primary layer. So anytime you move your cladding away from the wall, you're helping the longevity of that system.
I think one thing that's important to note on this chart, Tom, is the UV exposure time of the product. Most of the work that I do is in general remodeling, and I think most remodelers would know that when you get into some of these, you know, 3-month UV exposures, you are starting to put yourself at a certain level of risk if you're doing a large exterior remodel that involves a lot of lead time products. So that UV exposure for me in remodeling becomes a pretty important data point.
Yeah, absolutely. It's just the reality that there's delays and things can take a long time, right? So, there's a range there that you can see with the felt paper type products like the Jumbo Techs and the Super Jumbo Techs are 30 days because they're essentially like the classic tar paper, right? So they're limited there. As you get into some of the newer types of products like the polymer based, you can see that those are a bit higher, right? Between 6 months, even up to a year with the Weather Smart commercial product that's there. As we're focused on the VP 100 today, it kind of sits in the middle, right? 150 days. So
I've
closer.
uh, I've done in the past too, where I have it. If I've had a little bit, if I knew it was going to be exposed for a long time, I would put a sacrificial, something cheap that go to the big box store, buy a cheap WRB, stretch it out over the more expensive WRB, something that you pull off at the end just to save that.
Sure.
We had another question along those lines, Randy, that I'll hit you with now. It's from George in Climate Zone 3, who is doing some stucco work, and he's got 2 inches of polyiso with 2-inch furring strips between the stucco and the polyiso. And I believe his question is where to put that WRB in that layer. Should it go inboard or outboard of that polyiso layer?
I would probably put it against a moisture sensitive material. Because that polyiso is also a WRB. Basically, if you tape those seams, you said foil face, right? The foil face product, I believe. So if it is, and
Yeah.
you tape the seams, you've got
Oh,
essentially another WRB.
George clarified his answer there, or his question. He's wondering if VP 100 or a different product is the right product to use in that assembly.
Um,
Yeah, I think it would depend on the details of the assembly and cladding type and things like that. Certainly, there's advantages of installing the WRB behind the insulation, and there's advantages of installing it over. It's kind of dependent. As an example, one of the advantages of installing it over continuous insulation is you think about the process of construction, right? You typically have a plumber, an electrician that can come by after the fact and cut a new hole in the wall. If you have the WRB behind that insulation, it's much more difficult to try to seal that back up and flash it appropriately. So there are considerations one versus the other, and I think the preferences vary. I personally, I kind of like the WRB over for the reason I just mentioned.
Yeah, and yeah, I like it again. It's just because of the air
Exactly.
tightness and
Sure.
the windows are also a detail that you got to think through. If you're at the
100%.
sheathing layer, you've got to extend that WRB, that the protection out to the outside of the structure, which would be that insulation at that point.
Absolutely.
So one more question that I'll hit you with here while we have this chart up. Is the VP100 drainable if it is over flat sheet foam insulation?
If it's over the insulation,
Yeah. So would that be a drainable layer for the rain screen is I believe the question.
yeah, it wouldn't be considered a rain screen because a true, rain screen provides that actual physical separation versus a WRB product that has high drainage efficiency, which is that E2273 test that's been more common to talk about these days. It can function as that drainable WRB in either orientation. If you caught on that slide about VP100, it has a drainage efficiency above 95%. And actually, that test typically calls for a rigid foam over that layer. So either way, you're getting the advantage of that high drainage efficiency material. So again, we've talked a little bit about some of the properties of a self-adhered product. As you look at the VP100 product specifically, we've talked a little bit about the high perm rating to allow for uh, drying potential of the wall. Um, I just mentioned the high drainage efficiency. Of course, with this type of product, we're talking about air tightness. So air permeance is essentially what's the ability of that membrane to hold out air. And you can see that it's well below the requirement of the E2178 test. You, of course, got to have some durability of any product, right? So you want to make sure that you have a good tensile strength and breaking force as well as testing for back to the UV exposure, right? Is that material going to still have that same durability after it's been exposed for 3 months? So that's what some of those testing parameters are about is, let's really test the material and stress it to make sure that, as it's installed and left on a building, it can still perform 4 or 5 months later. So for VP100, it's 5 months at 150 days. Um, One thing that I haven't mentioned here yet, just in terms of fire performance, we have tested the product for the ASTM E84 test. It is a Class A rated product. Typically, I haven't seen that talked about quite as much in residential. However, what I tie that to is there is increased discussion, especially in California, with the WUI requirements. So that's something that starts to come into more consideration these days as you're looking at those types of considerations.
I had one clarifying question. The VP100 is a wall specific product. Uh,
Absolutely, yeah. That's a great distinction that this is an above grade wall product, so not meant for roofs, below grade, or horizontal surfaces. So if you have some sort of horizontal condition as a part of the wall system, there's details that Henry or any other manufacturer would have to address that for a WRB product.
I had one question as well about VP100 ever being tested for its effectiveness as a thermal break in a exterior rain screen system using Z channels. Uh,
Hmm.
I don't see anything in the specs about that, and I've only ever heard of that in more commercial products. I don't know if what your experience with that is, Tom.
Yeah, when you're talking about thermal breaks, you're essentially talking about R value, right? And the ability of that material to resist heat flow. With a product like a WRB in general, you're going to have a very minimal R value. It's going to essentially be negligible. So I would say that, you're not looking at a WRB to make that thermal break. And that starts to be where the continuous insulation comes in, right? When you install continuous insulation, that's your thermal break to minimize the thermal shorts through the studs because the studs can conduct the heat much faster than insulation does.
Right.
And I don't see Z-girts, at least me personally, in residential. That's a
Right.
commercial application. So
Yeah, I
typically,
think that would typically would, I'm not sure of the person who asked that question, but maybe it was a multifamily based question, and this product certainly can be used for multifamily as well. I think this is the last slide just talking about properties. In terms of thickness, 19 mils, it's 100 grams per square meter. So, a robust product from that view as well. We talked a little bit about nail sealability. That's based on the roofing nail sealability test, ASTM D1970. One thing that is, I always like to relate back to, again, tying back to the system, right? So assembly tests. So the ASTM E331 at the bottom there is a full assembly test where you install the product that you're testing on an 8x8 assembly, either with a window or without. And the VP100 was actually tested up to 15 pounds per square foot of water, wind-driven water is essentially what you can think about that as. To kind of relate that back to wind speeds, that's roughly equivalent to about 75 mile per hour wind-driven rain. So if you think about like a coastal climate, we see a lot of self-adhered products used in the upper Northeast on those coastal areas for that reason. And again, just some data to, highlight the advantage you can get with air tightness using a self-adhered product that's sealing up all of your sheathing joints, your top, bottom of the wall when integrated with flashing. You can see a clear difference versus a traditional wrap if not installed as an air barrier. And I think just to wrap up this portion before we hand it over to Randy here to talk about it, thought it was worth mentioning that there are more products on the market today that are integrating WRBs with other components, control layers of the wall system, right, to reduce labor time, reduce revolutions around the house, right? So a product that Henry has that was launched last year is Blueskin VP Tech. It's a EPS, actually GPS installation. I'll talk about that on the next slide, combined with our VP fabric self-adhered product. So kind of an all-in-one approach to continuous insulation plus a self-sealing WRB. The interesting thing here too is that it has integrated flaps. So that number 4 there is calling out that you have flaps that are built into that board so that when you install it on the wall, you simply remove the tape and cover over the adjacent boards. So again, the focus here is to be able in markets where you're installing continuous insulation to install the insulation and WRB all at the same time.
So can you talk a little bit more about this micro perforated polymeric backer? Can you give us a little
Sure,
bit
yeah.
of what that's doing on the backside of
Yeah,
this?
it's a little bit of a tongue twister there, huh?
Yeah,
Yeah, so that's just the back facer of the GPS insulation. So GPS is graphite polystyrene. It's essentially the EPS expanded polystyrene with graphite in it to have a higher R value. So that's the darker color that you see. To seal that up on the back is that back facer. And again, we've talked a lot about permeability here, right? So perforating it just helps to allow to have a higher perm rating for the overall product when you perforate it like that. Because it's on the inside layer, those perforations aren't really considered for water because the water drainage layer is the VP product on the outside of the board.
got it. So if you were to use the VP 100 over like a nail-based product, or maybe even if you decided to put it over some Zip R3 that had been out in the sun too long, is there any concern about trapping moisture, or is the breathability of the VP 100 good enough for going over that type of a product?
Sure, yeah. If you're installing VP100 over an existing product or a pre-applied sheathing, um, you know, typically you wouldn't want to install it when it's soaked or wet, right? You want to make sure it dries out. But if it's damp, certainly a high perm product like VP100 can still allow that sheathing to dry over time. So it's a good option for making sure you have that insurance of sealing that up and allowing the assembly to dry. Um, So just we mentioned systems, right? So Henry has what we refer to as a 1-2-3 warranty. So that's a WRB, a flashing product, and a sealant as a part of a full system to fully seal the wall system. So depending on the market, we've talked about different types of WRBs. There's different types of flashings as well, and as well as sealant. So we offer those options based on the different construction practices across the country and the conditions that they install in. So if you go to the next slide, Ian, we're talking about the VP 100, right? So what does this 1-2-3 system look like from a VP 100 standpoint, and specifically, Randy, what you used on your wall system, right? So if you look at the VP 100 and the advantages you get with that of the self-sealing WRB, a high-performance self-adhered flashing that performs can be installed at low temperatures as well. That's the Zero Flash product, and then a strong compatible sealant to make sure you have sealant at joints, behind windows, etc. And so what Henry offers there is a 15-year product and labor warranty if you use all three of those components together. Again, because we know that you get a lot more benefit of installing these things as a system.
When you're using screws for exterior trim, maybe you're going to use screws for your rain screen battens. Is there a difference in the sealability when you're talking about how the VP100 seals around nails versus screws?
It can be different, right? You have screws of different threads, different shank sizes, and the larger the shank, essentially, you talk about like a number 14 screw or a 1/4 inch screw and on up, it does become more difficult to seal. You will still get some good sealability with your typical trim screw, right, which is typically smaller. So I would say you're getting the sealability for that. But if you're talking about especially something like a lag bolt, right? You'd probably want to take some additional steps in detailing, which we certainly could provide to help make sure you're getting that sealability that you'd be looking for.
All right, up to me. So this article that we've been talking a little bit about is actually in Fine Home Building magazine. It's in the previous issue, August, September of this year, issue 333. Just a proud moment. That is my son on the cover.
I was wondering if you were going to
Awesome.
give him a
That's
shout
really
out.
cool.
Yeah, we had a lot of fun. Fine Home Building came out this before I started working with in the Fine Home Building family. They came out. We did some 3 days of video shooting of the project. It worked out well. The project is in Climate Zone 7, northern Minnesota. It's a small structure. It's just over 1,000 square feet. It was a simple structure. Um, and the goals were something that were very airtight, well insulated, and we basically made it as a code minimum wall build, right? It's the 2021-2024 code cycle, and even before that had continuous insulation. My area of Minnesota, we don't have the requirement of continuous insulation in our structures. Um, to simplify this project, to reduce costs, what we did is we built 2x4 in Climate Zone 7. It's we need to have some R value in that wall assembly, right? And to gain that by using 2x4 is to add that exterior insulation. Air tightness, of course, the Henry Blueskin happened to be the perfect product for this assembly. We had standard wall sheeting, OSB wall sheeting. Very simple again to build. We started, I mean, this detail really shows what we did well. We've got some slides coming up. Matter of fact, you can move ahead, Ian, and what we did on the bottom detail. This is the typical detail that you would see for a wall assembly. This is directly from Henry. This does not include continuous insulation on the outside, but it's really important to make a connection between the wall and whatever the foundation is. That's a really, when I do blower door testing, I'm doing testing of different structures. That is one of the areas that I do find a lot of air leakage at. There's a lot of methods to make that airtight. Personally, I like to use a tape when possible. The next slide actually shows what we did. The photo to the right is a piece of tape. It's not a Henry tape, but it's a piece of tape that we use from the OSB. It goes underneath to cap the bottom side of the OSB, and then it goes to the concrete. That's our air barrier. It's also a water barrier, right? Water is going to have a very difficult time to get underneath that
And
assembly
an
now.
insect barrier.
I was going to raise that same thing.
Yep,
It's sometimes overlooked that you can get that advantage there, right, of
yep,
blocking the insects.
yeah. Get the critters out.
Yeah.
Exactly. Uh, After that step, this is a frost protected shallow foundation. So the foundation thickness on the slab edge is a little less than 2 feet. And we put a piece of actually it's mineral wool, 3-inch mineral wool, rigid mineral wool against that, and then covered that with just a bent coil stock. And the picture to the left shows that detail. Uh, Now we're airtight. We've got our protection to the insulation.
And we should add, Randy, that that tape does not supersede using sill seal under that
Correct.
bottom plate
True.
in this scenario.
Yeah, it's not a capillary break. Of course,
Right.
that's on the bottom side. So yeah, we did put a sill seal underneath as well. I'm not a fan of a sill seal for the air barrier
Right.
because especially on concrete, the concrete's up and down, and a lot of times you do get gaps. So this is kind of a belt and suspenders, but it is the best way to get a really good air seal at that joint. Um, After we got that portion done, then it was just a matter of installing the blue skin, the WRB. Just so you know, this product comes in a 4 foot wide roll, right, by 100 foot. Um, if you can imagine taking a 4 foot wide piece of tape and sticking it onto the side of the building, that's what you're doing essentially. What we did is we snapped lines. We installed one area. Well, the majority of the house is installed uh, horizontally, right? We just stretched it out. We snapped lines. There's a split release on the back side of the product, so we were able to start a little bit of the release to adhere that first little bit of the blue skin, and then slowly start peeling. We did the top side first. Slowly start peeling that top side around, following our line that we chalked on the side of the building. Once we had that in place, we rolled it and then worked the bottom, and that lapped down over that metal or that metal flashing for the covering that bottom insulation detail. There was one side of the building that we decided to do a vertical application. It was We were trying to save a little bit on product, so we weren't wasting a bunch. It was more than 8 feet tall, more than what a 4 foot piece of blue skin would cover. So cutting that horizontally helped us in that application. That's actually a little easier to work if you're working solo. Is the horizontal? You can use gravity to help you out a little bit. If you're working the horizontal method, you're going to want two people. The other change is that when you're working horizontal, there's a 2-inch lap required. So from the upper to the bottom portion, you want to lap that 2 inches. If you're working vertically, it's a 3-inch required per Henry's instructions. It's a 3-inch lap. So just a little bit different there.
So
Um,
when you installed this, did you still follow the traditional methods of getting the shingling right, doing the other kind of self-draining methods that you would use with a non-self-adhered WRB?
as much as you can. There's some through wall details, for instance, the photo on the right there where
Yeah,
we've got a gasket. There probably would have been a method that we could have used if we wanted to slit that. But a lot of these penetrations weren't located. We weren't exactly sure where they
right.
were going to go. They got added after the fact. And when you're doing that, I think there's a slide further on that we can discuss this a little bit more. But there's a specific step that you want to take uh, once you get to this point in that photo, there's one more step you got to do. And we'll talk about that, I think, later on when we get to that point of in the slide deck. Oh, we're there. Reverse lap. I guess it's here. So the trick is to put a bead of sealant across that very top portion of the tape. Um, that's going to give you a little added belt and suspenders if you want for water management. We can't get water behind that tape. If water gets behind the tape, it's going to work on that adhesive and it will eventually let loose. And this added little piece of sealant, which is they use Henry specifies their 212 sealant, which is a clear sealant. You just put a bead across there, take a spatula or some kind of other tool that you can trowel it out, make it flat, and just prevent water from getting behind that assembly. Easy.
Here's a great
Yeah.
usage of a self-adhered WRB.
Yeah, this is not the Fine Home Building project. This is my house. This is something that I did this in 2019. I have a 1952 Cape that has board sheathing on it. And one of my goals was to improve the air tightness. And what I did is we peeled off of course the old cladding, the tar paper, which had quite a few holes. I don't know if they were there when it was originally put on, or if it was something that formed over the years. I don't know, but there were quite a few holes and rips and tears in the WRB. And replace it with a self-adhered. And again, my main goal was to improve the air tightness. The bug issue came as an advantage. Now we're sealing up all these little holes and penetrations where bugs are going to get behind the cladding. If they find a pathway, this board sheathing with all the gaps is a perfect place for them to get in. I did wrap Henry Blueskin down onto my foundation a little bit. It seemed to work. I haven't tried it. As a matter of fact, it's still sticking, but I did use a primer. Henry has got a spray-on primer. I applied primer on the concrete, kind of folded it up underneath the exposed wood, and then down onto the foundation. My only concern with that is it is exposed a little bit to sunlight, and I don't know. It seems to be holding up. It's not. I haven't found any places that's torn or disintegrated or fallen off. I really should probably cover it with a different tape or some other kind of a product that is got a better UV, but seems to be holding up. This house I did solo. I did install the whole thing, in a vertical flat fashion. So back to the Fine Home Building project. These are windows. Now we got 2.5 inches of continuous insulation. We used a rigid mineral wool on the walls. And what the process of what I did is we oversized the window rough openings by 3 inches. Um, we Before we started the WRB install, we took a router and we routed out the OSB over the rough opening, and then we extended the window buck out. That it's actually more than 2.5. It's 3.25 inches is what it sticks out past the frame of the house, and that extra 3/4 of an inch um, is actually lines up with our wall strapping that our cladding is going to attach to, and that's also what's really holding the insulation on the wall. Once we got the window bucks installed, we sealed those up really good. We've got a couple of beads of sealant that went between the rough opening and the window buck itself. We fastened that all in, and then we took and cut the WRB back 2 inches away from that buck. And what that's allowing us to do is take that tape that's got a really good bond. It's more adhesive. It's got more adhesive than the house wrap. We're able to span that OSB and then onto the window buck itself. So I'm very confident that we're not going to have any water leaks in that location as long as we did all our lapping correct. We started at the bottom, of course, and then worked our way up the sides and did the top last.
I think that's one concern a lot of people have when they start using tapes and self-adhered membranes is that they're going to start stacking all of these building products on top of each other, and it's going to kind of do the same thing that a lot of taping compound around a door casing does to you when you go to case it. It makes it challenging to get your finish materials to fit correctly. So I really like the 2 inch cutback.
Yeah, yeah, and the insulation flowed right over that. You know, you do have to work. You want to make sure you got a nice crisp, there's crisp as you can in that inside corner. You know, I use it's actually a wallpaper smoothing tool. It's just a plastic, a little bit wider tool to work all the tapes and the adhesives in these awkward corners, and it works well.
Another great tool that's very similar is like a carpet tucking tool.
Hmm.
You can get those at any box store, and they do a nice job of helping to get into those tight corners as well as get the right amount of pressure over the flashing as well. Manufacturers often talk about rolling the product or using firm pressure, but it's over the entire area of the product, right? Any self-adhered flashing is a pressure sensitive adhesive. And so
Right.
you do want to make sure you get good pressure over the membrane to make sure you get good adhesion there. So love that suggestion for the drywall tool.
Yeah, if you're not using if you're not getting that corner tight, a lot of times what I had, and that's the same as with WRBs. If you have an inside corner and that corner isn't nice and crisp, the siding crew often comes in. If it's not
Yep.
you, then they're gonna take their knife and they're gonna go right down there. And if it's
Cut
a,
cut
yep,
that baby out. Get it out of the
exactly,
way.
get it flat.
For
And
inside corners on a house, on an inside corner of a wall, I mean, using just a 2x4 sometimes is helpful for a larger section, right? Just to put it into more with the mechanical as well.
yeah, we lost part of that, Tom. At least I did on my end. I couldn't hear that. You're kind of breaking up. Yes, having a 2x4 or some kind of a solid structure to push into that corner to help get that tight, I think is what Tom was mentioning.
Yeah.
Sorry about that, everyone. I think my internet
Yeah, it's still a little fuzzy on your end.
We'll
Um,
we'll just keep moving on with Tom
yeah.
frozen in time there.
Another another suggestion is if you're using the blue skin, you can get blue skin in some different widths. You know, you don't have to get a 4 foot. They make 2 foot, or you can cut your own out of the,
Yeah.
one foot. I think they add down to 6 inches. Sometimes using those smaller pieces in corners is helpful. I think we have a slide coming up on an outside corner showing a little bit of that.
And above the windows too.
Yeah,
It's a lot of times it's nice to have that. And you brought up working alone before, and uh, that just seems like you're glutting for a punishment if you're gonna try and install a self-adhered WRB alone.
yeah. I had more than one piece that ended up in the garbage,
Yeah.
unfortunately, but it is what it is. Anyways, the picture on the left, again, my son, we're working around the window. We had the top and the sides completed at that point. You can see that there's no water resistive. I left the blue skin off from the very top of the window. And what I found is that once we get the window installed, we have our head flashing. This head flashing is pretty unique. It's got multiple bends in it. It's got to go back to the sheathing. It covers that top of the window buck, that 2x window buck, comes down and covers the top of the window. So we got multiple steps in there. Once that was all in place, then we came in. We actually put another layer of tape to the top side of that metal flashing, and then we went over all that with a new piece of WRB with the self-adhered. So I'm confident that the tops of those windows aren't going to have any issues. That all should drain down
Am I
very
seeing
well.
that correctly? That's a really tall top leg
It
on
is.
that
Yeah,
window head flashing.
it went up probably at least 6 inches. So
Yeah.
it's up there quite a ways. Yeah. This is the Henry detail. I've seen a few different ways that you can do this. That when you're dealing with a self-adhered, sometimes you can leave a little piece or apply a little piece of the backer back onto where the top side of the window is, just to make it a little bit easier so it's not stuck. I like cutting it up and adding it after the fact. It was easier for
Yeah.
me. Um, I don't know, Tom, do you want to say anything about this method?
Can you hear me okay?
Yep.
We
Yep.
got you.
Yeah,
Yep.
apologies for the
You
technical
were
difficulties.
you were doing your best Han Solo impersonation there.
There you go. That's right. Yeah, we do have different methods to address this. Like you said, Randy, there are considerations because it is a self-adhered. You have to take into account the release paper. We do have details that actually show the flashing just to the blue skin as well. Of course, that's a reverse lap, and we talk through at any reverse lap, we use that 212 sealant to bond and it does a nice job of bonding the flashing to the blue skin to make sure that even though it's a reverse lap, you're not getting any water intrusion behind it.
Yep. Corner details. Personally, I try to run the blue skin around the corner for a ways, then cut it off. So we're at, several, if not a foot, at least multiple inches, 6, 8 inches past the corner, and then we'll pick it back up. With two people, you can actually even keep going if you wanted. If you wanted to leave that continuous, we did that in a few instances. If you're by yourself, probably don't try to do that. Yeah,
Yeah.
you're going to want two people. It is a little bit more of a challenge. And that's our project before insulation went on. I had one door that we had left to address. But yeah, this is where we were at.
Those are great overhangs, by the way.
Yeah, yeah, 2 foot. We're well protected.
Yeah, back to the 5Ds we talked about, right? You got deflection all day there. It's
Yep,
nice.
yep. Again, Henry wants at least a minimum of 3 inches on the corners of overlap. And again, I would even do more. It's easy to go past. And if you need to, if you're having difficulties, again, they make the shorter rolls. A 1 foot roll would be perfect in this application where you just cover the corner and then you start, off the corner and go both directions.
Tom, these are really informative details. Is there some place that you could direct the listeners to go for these details on your website?
Yeah, absolutely. On any of our products, we have a product page. So if you just Google VP100, you should find the page and scroll down and you'll to the architectural details section. That's what you'd be looking for. And there's a list there of all the details that we offer. I would say if you have a detail, there's so many different conditions out there, right? So if you do have a detail that you don't see there, please do reach out to us and we'll work with you to address that. It's always fun to try to solve those complex details that can happen, right? I know you had experience there with your bump outs, Randy. Those are really nice installs.
Thank you.
Speaking of details, Randy, was there anything specific that you did at the top of the wall? And we talked about the bottom of the wall and the windows. What
Yeah.
did you do at the top to air seal that?
Yeah, even before we started the blue skin process, what we did is we took a wide piece of tape. We we had the OSB ended about midway between the top and bottom top plate. So we were lapping onto the I think the bottom of the top plate. We took a piece of tape, went from the OSB, it slid back to the rough framing, the two
Yeah.
by the top part of the top plate up and over the top of the wall. This was before we set trusses. And then we had a small piece of tape that still had the backer on that was hanging inside the building. And the way that the structure was designed is we didn't need any of our interior walls. The trusses were self-supporting. There were no interior bearing points. We were able to come in and put a membrane sheet across the entire building on the lid and then apply that tape to it. So now we had
Yeah.
continuity via our area control. So we were sealed at the foundation. The blue skin sealed our walls, our windows were detailed, and then that continuity actually went up and over the top of the wall and then into the structure. There's different products, different methods of doing this. I've seen people use strips of coated OSB where they actually put a solid piece up there. You can use membranes. If you're using a mechanically attached WRB, you could probably flip that up. You probably use blue skin if you can strip that make sure you have that backer left on it so you can attach it to the
Yeah.
no the yeah, so you could be able to attach it. That might be the hard part is making sure you have that little slip without
Yeah. The
the
The hard part is thinking about it before you get excited about swinging trusses
Yeah,
onto the structure.
yeah.
Yeah,
And then
it's definitely a sequencing and planning but you get a great advantage there of that continuity, like you said, Randy. I actually caught that on your first slide of the showed the article. I saw the little bit of tape there. I was like, man, that's a
yeah,
nice detail.
yeah, I've done that on several houses. It works well. This house tested when we were at Ruffin before we started any interior finishing. We were at zero point 0.3 ACH 50, but the house is small, and that metric doesn't work really well with really small houses.
Right.
Our actual air leakage rate at that point was 60 CFM. So you think of a bath fan. A bath fan is a blower door test in that structure. That's how tight that structure was. And we got a little bit worse. We ended up poking a bunch more holes out of it for the heating system and different ventilation stuff that went in, but we still ended up about double that. We're still a dryer is more than the blower door test on this structure. So it worked well. Uh, Back to my house. Now I don't have continuous insulation on my structure. I have the board sheathing, but I wanted to make sure that I had a really effective drainage behind the cladding. I have a wood type cladding. It's the LP Smart Side is what I ended up using on my house, and I wanted to make sure that that stayed off the WRB to allow both drainage and drying, free drainage and drying. And what I did is I took 3/8 strips of plywood and nailed that on all of the framing members, all the studs straight through the board sheathing, and that became my nailing point for my the cladding. Of course, windows and doors. I replaced all my windows and doors, so I was able to get that 3/8 behind, make sure that the windows and doors got out within plane, a better plane of the cladding. Um, you can see in that bottom right, when you're dealing with board sheathing, um, you can't catch all the air leaks. That happened to be the bottom of a window that did get covered, but when you're on the top of the wall, unless you're framing new, there's no way to get that blue skin really tucked up in that area where the tops of well, you probably could if you want to take a lot of time slitting between each truss, you might be able to get it folded up over there. But those are probably the weak points of my structure. I'm going to have some leakage that is going to come down at that very top, get into the wall, into that gap, and then into the structure at some point. I also have an interior membrane that's also installed airtight, so I'm kind of doubled up. Um, Once my roof is on, I can do a final blower door test. I'm hoping to be much better than I am now, where the last time I tested, I was at 9 ACH 50, but the majority of my leakage is my roof. That's my issue with this structure. Again, I did that solo. That whole house I did by myself. I ran it vertically. I used gravity as a friend on that. Uh, I worked in pieces that were no longer than 10 feet for the most part. So where I was on the gable ends, I do have a lap that laps down over the previous installed. Everything is shingle lapped on that. Um, this is where I made some modifications to the original stuff that I did. I did not I wanted to have a positive lap on the windows. You know, I could see where that 212 sealant on the top was going to be just fine, but I like having that for sure, not
Yeah.
having a leakage point there. So I changed my install a little bit, made sure I had a positive lap over the top of the windows with the blue skin product. How many questions do we have?
I peppered you guys with them while we were going through it. So I think
Yeah.
we
Yeah, good questions.
had a lot of great questions. There was some good stuff going on in the webinar chat as well. Uh, Tom, do you have anything to add here? Ways that they can reach out? You got a QR code on this last slide. Any other suggestions that you would have for people who want more information?
Sure, yeah. I mentioned earlier there's tons of information on our website, of course. But yeah, scan the QR code. Please do follow up with us if you have interest or if you just have a detail that you're curious about, even if you're not using our product, we'd be happy to help you. Um, like I said, it's fun to solve some of those challenges that you ultimately run into. So appreciate everyone's time today.
Yeah, I want to thank everybody for joining us. Most importantly, I want to thank Henry and Fine Home Building for putting this webinar on. Definitely thank Tom and Randy for joining me. And thank you all for joining us at home, and tune in on the next Fine Home Building webinar. Everybody have a good night.
Thank you.
Thank you.